Hello, grade 12 students. Mr. Rowell here again. Welcome to the beginning of our Encryption Decryption Challenge Problem-Based Learning unit. At this point, you should be starting to feel comfortable with getting data retrieved from files and exporting information to files, writing to them. And in this section, we are going to be approaching things in a bit of a different way in order to practice actually changing the data that we gather from files to encrypt it, and at times also attempting to do some decryption work on some very basic ciphers. Now, the way this unit is going to work is a bit different. Keep in mind that I'll be assigning you various levels of challenge problems. And whatever problem level you're able to solve by the end of the time that I have given you will determine the score that you get for the skill portion of your assessment. We'll see how far along you can get the layers of challenge. I'm hoping that most of us are able to get to the 7 or 8 range to get to some really interesting, more complex encryption level problems. For the most part, I'm going to be allowing you to work through this on your own, involving your own intuitions, ingenuity, and research skills to support you in solving these problems individually. But I want to get you set up on the right foot just to make sure that we remember some of the strategies that we can use to be able to do some of this work and to get ourselves just kind of started on the right foot for the first layer of challenge at level 1 and 2 range. The first thing that we need to remember is that we have this ASCII table, which shows us that various characters are correlated to numbers. We can actually go back and forth between numbers and characters in our programming language. For now, we're going to be wanting to focus on primarily 65 through 122. Actually, we'll go all the way. We actually want to consider the space in here. So 32 all the way to 122, space through Z. Now, for some of our simpler ciphers, we might just want to work at just the normal lowercase alphabet, 97 to 122. There's also an expanded ASCII table with many other types of alternate characters that it goes up to 256. You might want to consider using in some of the higher level challenges, but actually for now, we're just going to worry about 97 through 122 in particular. We want to see with our own eyes how this transferring back and forth between characters and numbers work. So I'm going to start by defining a new primitive character called letter, and I'll be assigning it, let's just assign it the first letter, A. Remember the single quotation to assign a character. And now I'm going to create an int called A that I'm going to assign the value of the letter A to. I'm going to do that by casting the letter to an integer. Let's see what the output is when we run this. The number associated with A is 97. 97 in our ASCII list is the value of A. Cool, the decimal value of that character. Let's just check out another one just to make sure this is working. Let's take a look at the end of the alphabet here, a Z, 122, bam. I recommend you try this out yourself just to make sure that you understand what's going on here. However, we can also work in reverse. So A is an integer. What if I said, now let's go back to the letter A here at the start. What if we said A is A plus 10? We increment it by 10 units. And then what we did is we said that letter equals A cast back to a character. Then we print this out. See what happens here. We get the letter K. 97 plus 10 is 107. 107 is the letter K. So I just changed the value of that character by doing a little bit of math, applying an algorithm to it in a sense, a really simple one. Yours in the future will be more complicated. And by using casting, I'm able to transform between characters and integers. This allows us, basically unlocks the ability to perform a cipher, where we take in all of the different characters of an input, we adjust their values mathematically, and then we turn it back into characters to print out an adjusted message that should be nonsensical and encoded for whoever the prying eyes might be that are taking a look over it. Let's see the basic way that we can approach this with a bit of a setup here. I'm going to create a custom method. That is going to be returning an array list of strings. Hopefully you remember this type of data structure from last year. Array lists are really good for this. Array lists are superior to arrays in one main way, which is that they automatically adjust their size. I don't have to know in advance the size. When I create an array, I have to tell it when I create it what size it has. But an array list will automatically adjust. It's a bit more inefficient, but for the purposes of this activity, the benefits are going to outweigh the costs in most cases. So we're going to be returning an array list. I'm going to call this getFile. And I'm going to send to this the file name of the file that I want the information from. The reason that I'm doing this is that I want to have within my program a copy of all the information from this file that I can alter, play with, and ultimately encode. So I might have some file that I'm going to work with. We'll create this a little bit later, but for now I'm going to create the logic of this. Don't need to know what's in the file just yet. So to work with this, I need to create a new local file in here from the file name that I had sent to this. I need to have an array list of strings. I'm going to call this my data. And it's a new array list. And let's remember how the notation for this. The data type that's stored in the array, I've already referenced it over here, so I don't need to put it in here again. I need to actually import my array list here, just to remember doing that, as well as my file class to be able to work with this. And I also want to have a string called temp that I'll be using in my logic down below here. I'm working with file input, reading from a file, so I need a try catch block. Just IO exception E. Let's print E to the console, import that exception, and now we'll see what we do inside this try block. I'm going to be reading from a file, so let's get our file reader. And I will be reading from that file that I imported. Next, let's load in my scanner. Import my scanner here. Awesome. All right, now let's set up the logic. What am I trying to do? While our scanner has a next line to read from, we'll perform some tasks. The task that I need to perform is that I am going to assign to my string temp the values of the next line that I'm scanning. So I'm temporarily storing all the data from the next line that I've scanned from that file in this string. And now in my array list data, I'm going to add that string as the next entry in that array list. This is going to scan through the whole document, gathering every single line until the end. Each line will be stored temporarily and then added permanently to this data structure array list. Once this is done, I want to make sure that I take my file reader and I close it so that it's done scanning. And what I have now, by the end of this whole while loop, is the entire file stored in this array list. Now, what I need to do at the end here is I need to return that data to whoever's asking for it. Now, what I can do in my main up here is I can create an array list of strings called, we can call it, I guess, data up here. Data to encode. Why don't we just be really detailed here? And this is going to be a new array list. Typo in there. Watch for all these capitals. So, data to encode. Now, actually, I don't necessarily need it to be a new array list because I'm actually going to reference this method here. I want this to be get file from whatever the name of the file is. So let's dive into my Crypto example here. Let's create a new text document and let's call it to encrypt. Inside this file, let's write a little bit of text here. You will never guess what this message says. I want this message to be encrypted in some way. And so what's the file here? It's going to be to encrypt.txt. So when I run this, it should temporarily store inside my program all of the information inside of this array list. You'll never guess what this message says. All that information is stored within the array list itself. Wonderful. Now I have that stored within my program itself. It can be of any length. Of course, the longer it gets, the more inefficient the array list is going to be running, but for the purposes of this project, it should be sufficient to deal with any scenario that we're coming across. All right, now we need to do something to encode this file. You're going to be adding more sophistication onto this, but for now, let's make sure we understand together how to encode this. So, we are going to be encoding a file. We are going to be receiving as input the data from this array list of strings. I keep on doing this, the L lowercase, no problem. So we want to be adjusting the information and then assigning it to a new file that's encoded that will be stored in our project file here. So what's the file that we want to be encoded here? Well, we're going to call this file encrypted, and we'll call this an encrypted file, a new file that we're going to create from scratch. All right, so here's what we're going to do. We are going to try and catch our IO exception. Feel free to add more customization into your output messages. For now, we're just going to keep it nice and simple in this structure. And what I want to do is actually have a print writer be working here. Output, a new print writer. And I'm going to use my shortcut here. I'm going to create the file writer from my file encrypted within it and import those classes to it. Remember the shortcut way of doing so, kind of combining those two steps into one to keep it nice and tightly organized. Awesome. So I'm going to be writing to this file now based off of the data that I have in my array list that I've already gotten from the file up here. So I have this data to encode. Later on, I'll be sending that here, but let's first set up the logic. So let's think, what do we want this to be able to do? We want this program to be able to read all of the string information and also actually the characters within that string from the file information that we have. We want to adjust the values of those characters by some amount by turning it into a number, incrementing or decrementing that number, and then converting it back to a character so we get a coded message. Here's how I'm going to structure this logic with some nested for loops. First, I'm going to say for int I equals 0, I is less than the size of our array list, incrementing I. So for all of this, now that's going to loop me through each element in my array list, however many different unique elements I've added. Remember, each time I scanned a line, I added a new element to that array list. So could be 1, could be 100, could be even more. It's going to automatically go through each of those elements. I am then also going to loop through in an inner loop. Inside that array list, I'm going to be getting the location of the array entry I. So each one that I cycle through, I'll be going through these one at a time, and I will be getting the character at J. Now, did I have not enough? Oh, I don't need that outer bracket. No, I should. Oh, I forgot. Plus J. There we go. And we'll close this off here. So we're going to be looping through each individual data piece that we loop through. We're going to be accessing the information within that part of the array and then examining each of the characters within that individually. So we're going through one character at a time through all of this data. Now, I'm going to set a temporary character. That's going to be equal to the part of the array that I'm looking at, and the character at the spot j. That temporary character, I am going to convert it to a temporary integer by casting it to an int, just like we did in the example at the start of this lesson. Then I am going to create an altered character. Here's how I'm going to set this logic up. I'm going to take that temporary integer and I'm going to add some number to it. Let's say I want to adjust the values by 5. Once I've adjusted the value by 5, I want to cast this back into a character. So the altered character is adjusted here and cast back into a char here. And maybe just so that we can see what our message looks like within the console as well, let's have an output. Oh, sorry, we're actually going to be taking, my bad, I jumped ahead of myself. We'll do that later on. We want to take this altered character and we want to write it to our encoded file, our file encrypted. So we are going to output and print this altered char to our encrypted file. Now outside of these loops, this should cover every single character in the data that we sent to it, which is all the information from the original file. We've altered the contents by shifting it by 5 values and converted it back to a character to be able to be actual like readable information in English or some encoded equivalent of it. And outside of it, I'm going to take my output and close it so that that file is no longer being written to at the end here. Now what I should see when I run this is if I go up here, now I've already encoded this data. I want to say, I've already gotten the file, the data to encode, I've gathered it. I'm going to encode the file by sending it this data to encode. When I run this, I see the message there, and I should see my encrypted file popping up, which shows all the adjusted characters. Now it's kind of gibberish. Just to show you that these things are a bit different here, I'm going to copy the information of this file. We're going to go back in here, and we're going to change the number of characters that this is shifted by. Let's go to 10. Let's run this again. And in my encrypted file, I'll paste the original message. We'll notice that just by shifting that amount, the encoded message is very different. This is the original one, a shift of 5. This is a shift of 10. Good luck reading this if you're looking to kind of get the secret information of the file. Here's a starting point of how we can think through the logic of encoding a message. It's up to you to make this more generalized for any number of adjustments, as well as wrapping back around with numbers. So keep in mind that if we were to reach 122, maybe we wanted to extend into more special characters, or maybe we wanted to wrap back around to starting at 32 or some other point. That's some logic that you have to consider encoding into your own methods, as well as the process of decoding, which at this beginning is as simple as having a process work in reverse, with the opposite adjustment going and taking place. From there, the challenges get a little bit tougher with adding some more layers to things and having your program trying to do some intelligent decoding of its own. But I'll be around to help you out thinking through the logic of some of those things. I may make another tutorial video in the coming days to help guide you through some of those more complex pieces of logic, but for now, the task is there before you. Using this basic idea of how we can adjust the values of a file and encrypt it, let's see what you can do about tackling those various levels of challenge in the project-based learning assignments. Please do not jump ahead. Tackle the challenges one at a time. Do not move on to level 3 until level 2 works. Do not move on to level 4 until level 3 works, so on and so forth. Good luck. Have fun with it. This is a really cool opportunity to showcase how well you can process unique algorithmic thinking. Best of luck.